Hi students, welcome to my YouTube video. Today we are going to discuss about problems on heat IC engine and performance of IC engine. This is first problem. We are going to solve this one now. A heat engine has a piston diameter of 150 mm, length of stroke 400 mm, and mean effective pressure 5.5 bar. The engine makes 120 explosions per minute. Determine the mechanical efficiency of the engine if the engine BP is 5 kilowatt. This is the problem. So in this problem, given is diameter of piston, means nothing but a what? Diameter of cylinder. So this here, this is the what? Cylinder. In this is the piston, and this diameter is given d, nothing but a small d, 150 mm, and length of stroke is given. So means this is TDC, and see this is BDC. This length of stroke is given. This is 400 mm. Then mean effective pressure means the pressure remain constant throughout the stroke is called mean effective pressure, that is 5.5 bar, and the engine makes 120 explosions per minute, means in 1 minute 120 mm, 120 explosions means what? In 1 minute the engine makes 120 power stroke. Then determine the mechanical efficiency of the engine if BP is given 5 kilowatt. This is the problem. So in this problem we are going to determine the mechanical efficiency. As we know that efficiency equal to what? Output by input. In this chapter, that is nothing but what? BP by IP. So in problem, BP is given but IP is not given. So first you have to find IP. For that one, given is diameter of piston is given, that is nothing but D. Then length of stroke is given, that is 400 mm. For that, first we have to write given data, that is diameter of piston 150 mm, means you have to convert in terms of meter, that is 0.150 meter. Length of stroke is given 400 mm, that's equals to 0.4 meter. Then P suffix m means mean effective pressure 5.5 bar. Then small n means what? Number of explosions 120, and last BP is 5 kilowatt. So as we know that area of piston equals to, or you can write area of cylinder equals to pi by 4 into d square. So pi is a constant 3.142 divided by 4. So d equal to 0.15 square. That's equals to 0.0176 meter square. This is what area of piston. Then IP equals to, we know formula, 100 into PM into LAN divided by 60, means 100 is constant, then PM is given 5.5 bar, L means length of stroke, that is 0.4, then area equal to 0.0176, then n equal to number of explosions, that is 120. So whole divided by 60. Then substitute all the values in IP formula. Then that is equal to 7.74 kilowatt. This is the what indicated power. Now IP we know, BP is given. Substitute these two values in efficiency formula. Efficiency equals to BP by IP, that's equals to 5 by 7.74, that's equals to 64.5 percentage. This is the mechanical efficiency of engine by using that given data. So that is 64.5 is the mechanical efficiency of the engine. This is first problem. Then second problem is A diesel engine uses 6.5 kg of oil per hour of calorific value 30,000 kilojoule per kg. If the BP of the engine is 22 kilowatt and mechanical efficiency is 85%, determine first one indicated thermal efficiency, second is brake thermal efficiency, and third is specific fuel consumption in kg per BP per hour. This is the problem. Means there is a diesel engine, it consumes 6.5 kg of oil per hour, and that oil having 30,000 calorific value. So first you should know what calorific value means. It is amount of heat liberated per kg of fuel. Say for example, there is a 1 kg of diesel. After burning up that much fuel, how much heat is produced in terms of kilojoule? That is nothing but what? Calorific value of that particular fuel. Means diesel having 30,000 kilojoule per kg of calorific value. And the BP is given 22 kilowatt, mechanical efficiency is given 85%. So determine indicated thermal efficiency, second is brake thermal efficiency, and third is specific fuel consumption in kg per BP per hour. This is the given data. So next, move to the solution. Given is mass of fuel means MF equal to 6.5 kg. CV means calorific value of fuel, that is 30,000 kilojoule per kg. BP means brake power equal to 22 kilowatt. Eta suffix m means mechanical efficiency equal to 85%, that's equal to 0.85. So as we know that indicated thermal efficiency equals to, we know that IP mechanical efficiency we know in a previous problem, that is equal to what? BP by IP. And in this problem, BP is given, efficiency is given, unknown is what? IP. So just simplify the formula, mechanical efficiency formula. So can write IP equals to BP by mechanical efficiency, this one. So substitute the BP and mechanical efficiency, we can get 25.88 kilowatt of IP. This is the what? IP, 25.88 kilowatt. Okay, next is indicated thermal efficiency, that is equal to what? IP into 3600 divided by MF into CV. This is the formula for equals to IP into 3600 whole divided by MF into CV. This is the what formula for indicated thermal efficiency, this one. So now substitute the values of in this formula. IP equal to 25.88 into 3600 divided by 6.5 into 30,000. So after solving this one equation, we can get 47.7%. See here, 47.7% efficiency. Second is brake thermal efficiency, that's equal to formula we know, BP into 3600 whole divided by MF into CV. So in this BP we know given 22 kilowatt, so into 3600 because in terms of hour. Then mass of fuel we know 6.5, CV equal to we know 30,000. Substitute all the values and we can get 40.6% of brake thermal efficiency. This is what? Brake thermal efficiency of engine. And last is specific fuel consumption. As we know that the specific fuel consumption, that's equals to MF by BP. So by keeping the value of BP as it is, because he asked specific fuel consumption in terms of kg per pp per hour. So MF equal to what? In terms of kg, pp equal to in terms of hour. That's why keep as it is pp. So SFC equal to MF by BP. So MF equals to 6.5 kg. Here it is kg. BP equal to per hour is there as it is. That's why that is equals to 0.295 in terms of kg per bp per hour. This is the value of specific fuel consumption. These are the two problems of first chapter. First, this is the first, this is the second. So here, then third problem, during the test on a single cylinder diesel engine working on the 4-stroke cycle and fitted with a rope brake drum, the following readings are taken. Effective diameter of brake wheel equals to 630 millimeter. Then dead load on brake equals to 200 Newton. Spring balance reading equals to 30 Newton. Speed equals to 450 RPM. Area of indicator diagram equals to 420 mm square. Length of indicator diagram equals to 60 millimeter. Spring scale equal to 1.1 bar per mm. Diameter of cylinder equals to 100 mm. Stroke equals to 150 millimeter. Quality of oil used equals to 0.815 kg per hour. Calorific value of oil equals to 42,000 kilojoule per kg. So next, determine brake power, indicated power, mechanical efficiency, brake thermal efficiency, and brake specific fuel consumption. This is the what given data. So means during the test of single cylinder diesel engine, these are the following data is given. What? That is the readings of that single cylinder diesel engine. So in this you are going to solve brake power, indicated power, mechanical efficiency, and brake thermal efficiency, and brake specific fuel consumption. So first you have to write given data. Here k equal to number of cylinder, that is equal to single means what? 1. Diameter of cylinder is given 1630 millimeter, that is equal to 0.63 meter. Weight is given 200 minus n. N means what here? Spring reading 200 Newton. S equal to 30 Newton. N equal to RPM 450. Area equal to 420 millimeter square. Length equal to 60 millimeter. Small s equals to spring scale, that is 1.1 bar per mm. Then d suffix d equal to diameter of cylinder 100 millimeter, that is 0.1 meter. Length of stroke is given 150 millimeter, or you can write 0.1 meter. Then mass of fuel is given 0.815 kg per hour. CV is given, means calorific value 42,000 kilojoule per kg. So now first you have to find brake power. As you know that brake power is equal to what? W minus S into pi d n by 60. Say W equal to given weight of the brake wheel. S equal to spring scale is given. Pi constant. D is given diameter of brake. N is number of revolutions. Substitute all these values in this equation. So you can write, you can get 2.52 kilowatt. This is the what? The brake power of this engine. So next, IP means indicated power. IP means indicated power. So first you have to find mean effective pressure before finding the indicated power. Then this is equal to, means PM equals to area into S divided by L. A into S divided by L. A means area of diagram, S means scale of diagram, L means length of diagram. So area is given 420 millimeter square, scale is given 1.1 bar per mm, length is given 60 millimeter. That is equal to 7.7 bar. This is the what mean effective pressure. Next, area of cylinder, that is equal to area equal to pi by 4 into d square. So pi constant, 4 constant, d equal to 0.1 meter square, that is equal to 7.855 into 10 raised to minus 3 meter square. Then number of working stroke per minute, that is equal to, for 4-stroke petrol engine, small n equal to capital N by 2, means small n equal to what? Number of stroke, that is equal to capital N by small n. So capital N is given 450 divided by 2, that's equals to 225 explosions. So now substitute all the values in IP formula, that is 100 into PM into LAN into K. Here K equal to number of cylinder. So after substituting all the values in this equation, we can get 3.4 kilowatt of IP, means indicated power. So now we know that mechanical efficiency equal to BP by IP, and in this equation BP we know, IP we know. Substitute these two values in this equation, we can get 74.18% of mechanical efficiency. So next, brake thermal efficiency equal to BP into 3600 whole divided by MF into CV. So BP we know 2.52, then for in terms of hour, this is 3600 in terms of second. Then mass of fuel is given 0.815 into CV equal to given 42,000. So after substituting these all values in this equation, we can get 26.5% of brake thermal efficiency. The last is brake specific fuel consumption, that is equal to MF by BP. Mass of fuel is given 0.815, BP is 0.252, that is in terms of kg per BP per hour, that is equal to 0.323. This is the what brake specific fuel consumption. This is the regarding the third problem. Thank you for watching this video.